talk about what we should do in this day and age where things are changing very fast, and we want to know if you are in a solutions company, if you are a product company, if you're an engineer, if you're a decision maker, we want to know what should be your direction of movement in next, let's say, few months and few years. My name is Moe Sani and I work for Qualcomm. We used to be a software company called Edge Impulse, got acquired by Qualcomm. Day to day, I deal with different companies that they're trying to integrate AI into their workflows. It could be in industrial use cases, robotics use cases. So day to day, I deal with these different projects that has AI in it, and it made me think, what is the best strategy now, right? So I'm trying to summarize my thoughts, and it is evolving here. So I'll be keen to hear what you think about this topic as well at the end. So we will open the floor at the end to have some discussion. But let's talk about software. So we all know software has been really, really hot, selling like hot cake, right? So it was whatever software company you make, it gets a lot of funding in recent 20, 30 years. But it's getting easier to build, and we're going to talk about that part. Hardware is also getting cheaper, right? So when software is getting cheaper, the ability to make hardware, the machinery, all the tools, it's slowly getting cheaper as well, right? So where should you build the pillars of your company going forward? AI is accelerating both. So we normally know technology comes in waves. So we had different waves of the technology in different years. We know that one industry comes in, you have, I don't know, industrial revolution, you had lots of engines and cars and trains, and then you move on to the next one and the next one, which we should look at these larger patterns and start analyzing where the market might move the next, right? So normally the technology comes in, it becomes commoditized, it's not niche anymore, so people can just build the same thing as your company has. Let's say if you have a service software, a SaaS company right now, that, let's say, simplifies a signature on a document, right? You all know this company probably. The next day, it's not really hard for another person in their bedroom to come up and build the same one. So it's not a competitive advantage anymore. So slowly the value shifts to a different place when these sort of evolutions happen. So we had the mechanical era where mechanical systems were hot topic. Everyone wanted to build a new car brand or a new, I don't know, washing machine or a new, which that was electrical area, but we had the mechanical part, and then we moved to electrical. Everyone was trying to integrate electronics, electrical industry with mechanics. And then we had the electronics itself, computers and PCs came on, and phones, they were all hot topic. Then we moved on to the software, which is more recent. And the big giants in the software industry appeared. Your Googles and Amazons, and a lot of them are largely built on the software basis. Now the next one seems to be the AI one, which we know, but what does it actually mean and what should we do going forwards? Every time this shift happens, value moves upwards. So you need to now think, where should we build our structure and the moat of our company and the business? Or even if you're learning, what skills you need to learn to make this movement more efficient for you. So software in the last 30 years, if we analyze it a little bit more, the code was the moat because code was hard. No one understood how to write code. And then the software engineering prices the price for paying the engineers went really, really high. And then the platform meant that you could scale. So software brought the platform ability in. So you could just build something once and sell it thousands of the times. And the distribution was easier as well. But now the code is getting cheaper. So we know that 51% of the companies, the code generated in GitHub is now AI generated. So there is no illusion anymore. You know it is getting cheaper, right? And it's getting easier, right? It's not trustable, not this, not that, but the price of writing a software, let's say an online store software, compared to 5 years ago, is dramatically lower. No matter if it is wipe coded or not wipe coded, it's going to be cheaper to build this anyways. Development is faster as well, time to market is faster. So if you've been releasing a new feature in your company that is purely software, it's going to be in like a week time, your competitor is going to copy that and put it on the market. So we can't, the traditional business structure doesn't work anymore. You can't really base your pricing, your business model on the software. So what happens when software becomes cheaper? Feature differentiation, as I explained. Time to market. We know that the competitor can quickly ship product, and we need to now find somewhere else to build our value at, which is a stressful time, right? A lot of our day-to-day life has been evolved around software features, myself as well. And we are all lost. We are all lost. What should we do? Things are changing, and even as an individual, your job might be at risk as well. What should we learn next that we can actually have a chance of survival in this fast economy? So software, yes, is becoming cheaper, but one thing is remaining is that solid, integrated, tested software is still valuable, right? I don't think it should be still a business solid fort. It shouldn't be the structure of the business, but it should still be considered as something that you need to pay attention. And having a reliable software, deployable, tested, it's not easy. So let's remember that part. But still it gets cheaper. So where do we go next? I think the wave that we talked about is going to move into the physical world because it's getting harder. Yes, the software is getting easier and cheaper, but it is really hard to deal with the real world. So if you think about the latest, all the AI buzz, it's been all around like the software-y side of things, right? In your computer, you have an image, you have a voice, you have a, I don't know, text. It's all AI is built based on these like visual elements that is low risk and basically no real bad outcome could happen if something goes wrong. But what hasn't been solved is dealing with the physical world and taking automatic action based on the physical environment. So what do we mean by this? It means reading physical world sensors that are noisy. It's not just like a text that is defined. On the internet, it's very bounded. In the real world, you have noise, you have vibration, you have interference. Everyone that built a physical system and automation in the factory knows that a tiny bit of change in the lighting knocks off your whole algorithm. So these things are not easy, but AI is entering into that stage and is becoming helpful, and it's very, very early on. It's the time, I think, and I'm going to be keen to hear your thoughts on it. I think it's the right time to go and work with physical systems and try to integrate machine learning, simple, very, very simple parts of machine learning and AI. We don't need to solve like the AGI and bring a robot, humanoid robot that does everything in our factory. I don't think that's the way to go. That's just flashy marketing. I think we need to find tiny problems. Okay, I'm building, I don't know, like a ceramic tiles in my company. How do I increase my throughput and productivity by 2% by integrating AI? Can I make my products reliable? Can I make my supply chain reliable? Can I analyze my raw materials so I don't waste time, I don't know, building a faulty product? So all these things are the niche area that we need to move to. Now, what physical edge AI brings to you that you can achieve this purpose? What has changed recently now? The thing that changed was that LLMs and AI and all these things we knew traditionally, they were good at running in the cloud and massive computers. But now our hardwares, the literal MCUs and MPUs are running on the machine, are becoming better and better at dealing with these models. The models themselves are becoming smaller, and there are more software for you to be able to train your own custom model. That is the key, I think. We need to think about what our business needs in our niche area and go build that specific model into the workflow. We don't need to use generic ChatGPT or whatever. I don't think an industry is going to be useful. Yes, we have some VLM models that I will talk about that might be useful for a section of industry, but I think that is just leading the way, opening up the capabilities for us then be able to have our own custom models built and ready and deployed on the software devices. Now, another trend that we can see is we have a lot of now connected devices, everything IoT, right? Everything is connected, which means we have more data. AI is deployable, we talked about it. Real-time decision making is the key. In the past, every model that ran on the cloud, it has a lot of costs associated with it. There's a cost of waiting, so you need to send the packets to the cloud and back. You need to wait. So it's proven that the local models are faster than the cloud model. Even though the cloud has larger infrastructure, the communication latency and also the reliability drops, because what if you have a model that detects, I don't know, human safety not to go in front of a machine? You can't wait for the cloud and come back to disable this machine, let's say a saw. You need to have a local model that every time is just giving the same answer. This has been the missing piece in integrating edge AI into the industry. And the other one is the power. So on a larger scale, if you want to have every part of your system and your factory or your product to have AI in it, this AI needs to have lower power. Normally, antennas and communication consumes more power than running these devices and models locally. So that's another area to consider. When you run them locally, then your budget drops as well. And obviously you cut token costs that are now getting more and more expensive on the cloud. You all know it's like, or any AI models on the cloud, they're really expensive to run. If you have your own model locally, you save that money as well. Now, what are some of the use cases that we can think about? Of course, we have robotics. Inspection is a big part. We've had many companies and customers interested in this and actually working actively on this area. There is huge parts of industrial inspection that is untouched. It's just lots of money tapped. We could tap into it. Think about, we worked a bit on oil and gas, right? But it could be any areas. I actually just recently seen in China, they have these vehicles that have cameras in it, check the road quality, and every crack they have is spotted using Edge AI, and then just send the coordinates back to the main system. So these sort of things in every part of industry is possible to do. And manufacturing, of course, defect detection, automation of larger parts of your system, and you're going to see the benefits soon, right? So everything needs to be tied to the money. We talked about lower latency, reduced cost of the cloud. This is just a summary. Reliability is going to go up when you use your edge model specifically for your use case. That's the key. And you can then have this as a new feature rather than having a software or a change of a color or a new, I don't know, new chatbot as a feature. You could have physical features introduced. So what we need to remember is the code and the feature is gone. The new wave is going to be real world deployment of AI, not just demos. Demos are easy. You can walk around here, see thousands of demos. Which one of them are running in a scale in products? Data from physical system is going to be the key. Whoever has access to have more and more real world data is going to win this economy, I think. Because the data is going to be specialized in the industries. If you have, let's say, data from a specific machinery that has certain noise or characteristics, then that's valuable for that industry. You could automate it, right? So we have a customer who uses sound sensor and vibration to detect and predict the anomalies of the car engines. So with this, he goes, and imagine if you're an auction person who goes and buys cars from an auction, by just running this device on the machine and running the car, you could detect what sort of problems this auction car might have and save money there, right? So these sort of things solely rely on the data that comes from the real world. So this is the trend. Software that informs, which used to be, just informational software or IT. Now we need to move towards the machines that act. The acting is the big type. Right, okay, so some key takeaways here. And I'm going to talk about an example that we have as well after this, and then we will open the floor for some questions. Some key takeaways. If you have a product company, let's re-evaluate your product and see where Edge AI fits. And I'm happy to talk about it if you're interested. Where Edge AI fits into your business and where we can add real world touch into the product. And then the next phase, it will be how to deploy it, which is completely different story and changing the architecture. One thing I forgot to talk about is hybrid. Hybrid is going to become very, very interesting, I think. The solution shouldn't be either local or cloud. It should be both. The system now going to learn and going to be efficient on which task they solve locally and which task they send it to the cloud and wait for the response. And you're going to hear more about like agentic AIs and things like that, which is, I'm assuming, the next theme of, you see this year and last year, you're walking around the floor, you see everyone is Edge AI, Edge AI. I think next year we're going to go, everyone is going to be agentic AI. So let's prepare ourselves for that world as well. Right, so I'm going to show you an example use case that we built for one of our prospects here. So the problem was that they have long pipelines of oil and gas, and they wanted to inspect it if there is any leak, any corrosion, any damage. And we have the models now capable of doing it, but then how do you actually automate it and save hours of people's times? Well, we put it on this robot, and the robot runs 2 parallel models. So it has 2 camera streams. One model detects the joints that they're critical, and then the second model, that's from a zoom camera, zooms in and detects the specific corrosions or damage. This is not just about this oil and gas pipeline inspection. Think about how we can apply this into your industry. Everything comes from like some sort of sensors inputs, some sort of analysis in parallel or multiple, or in stages. Cascade is another, cascade machine learning is another topic, which I'm not going to talk about in this session, but mixing and matching of multiple small models that are very good at solving one task and then building a big system with it. I think that's the way to go, rather than sitting and waiting for a next wave of ChatGPT that is going to be great at, I don't know, solving all the problems at once. And then, so this is all running locally in our IQ6 device, Qualcomm's IQ6. And have a look at some of the hardware that has accelerator in it. The prices are going down, capabilities are going up. So, and the power consumption is crazy. Now you could run LLMs and VLMs on these. We have one in the booth to come and see. Could run LLMs and VLMs on these machines that are like the size of a Raspberry Pi. Yeah, so we have, if you were interested, we can talk about this more, but we have some pipelines about how to train your model, how to quantize it, deploy it, and manage your fleet, and also monitor your models back to see if the performance is keeping up or not. So this is what's our offering. And you can come to the booth S9 and see this robot moving around and analyzing the pipeline. So I want to leave some, maybe 5 minutes for some questions if there is. If you have a mic. Yeah. If you have any questions about these topics or any thoughts, if you disagree with this trend, I'm keen to hear your thoughts as well. Okay, cool, nice. Seems like everyone is happy that the market is changing. So yeah, I'll close the session now, and thank you very much for your